Okay, so we're doing 9-2 polar coordinates. This stuff is actually pretty easy. We'll have quite a bit of time for into class time for homework. It's just going to feel a little weird at first. So everybody, once again, taking some good notes, asking questions when you need to. All right, so here we have an XY point 3, 4. So how did we, if I wanted to get there, I would go 3 units. This little guy wanted to get to that point. He would walk 3 units this way and then 4 units up this way, and he's arrived at his destination. Now, can anyone tell me another way to get to that destination? Okay, good. So you're saying he could start right here at the origin, but then quicker get right there. Yeah, so you just created a right triangle, correct? So what we're doing today is we're actually describing another way to get to that blue point, just in a different format. The exact same thing, just a different format. So couldn't we say, by chance, telling this guy to get to that blue point, couldn't we say turn some theta amount, so from here turn some theta, and then walk forward this amount of distance? And that would get him there as well. That is the polar form of an XY point. Describing it instead of XY, describing it as a theta R. And that would get you to the same spot. So that's the polar form. Does everybody see? I haven't taught you how to do it yet, obviously. I'm getting you to see how it makes what we're doing today. Okay. All right. So we just saw we have right triangles, and I just told you that we could do it XY, or now we are seeing that we could do theta and then walk out our distance. So that's what this is saying. So it says right here, rectangular coordinate system. So far, you have been representing graphs of equations of XY points on a rectangular coordinate system, where X and Y are distances from the origin. Polar coordinate system is doing the same thing, getting to an XY point, but to form the polar coordinate system in the plane, fix a point O called the origin, and we will have the polar axis, which is our initial ray, and we open it to a point P. So basically we open some theta distance, and then we walk out that distance to get to that point. So we open some theta amount to get to the right positioning, and then we walk out some r distance. Now, why am I calling it an r? Yeah, couldn't I draw a circle? If we're starting at the origin 0, 0, and I walk out, couldn't I draw a circle and that would be my radius? If we start at 0, 0. Okay, yeah, so that's what is technically radius comma theta. All right, so let's see how to graph. Let me ask if this makes sense before I move on. Okay, so we're going to give you a polar graph. Now understand, guys, this is the same thing as having an XY chart. Here's my y-axis. We're just representing it different. Here's my x-axis, okay? I didn't draw that very straight, but that's okay. So this is a XY point, but it's not XY, it's a polar point, r comma theta. So what you actually do to graph these is you kind of work backwards. So normally we do x then y. With this one we go theta first. So we're going to locate pi thirds. Now that's along this line, isn't it? Okay, so now I'll do a pink point. Now this says go out a radius of 2. Now look, do you guys see how there's a circle of radius 1, radius 2, radius 3, radius 4. We have circles drawn. So we're going to start at the origin and go out 1, 2 radiuses. And boom, there's an XY point. Does that make sense? Okay, so like now if I wanted, in the future you're going to see, couldn't I represent that just as an XY point? Yes, it's just a different way of writing the same thing. We'll learn how to do that later. Let's practice graphing this one real quick. So this is go negative pi 6. So here's, once again, here's positive pi 6, isn't it? So wouldn't negative pi 6 be right here? So along this line, it's so hard for me to keep straight. And then from there, we're going from the origin 3 units. So that would be 1, 2, 3 units. Everybody good? Okay. Let's do another one. I think we get the picture. Okay. All right. All right, so everybody start writing this down. So we just saw we had a right, to get to an XY point right here. To get to some XY point, we could also represent to get to that by r comma theta, which created a right triangle. So let's come up with some true statements based on this right triangle. Now right here is my origin, 0, 0. We all understand that. And then we had a right triangle to get to this point right here. Okay, let's set up a true statement. Now isn't it true if we have this triangle that x squared plus y squared equals radius squared, Pythagorean theorem? So that's why I wrote down this first true statement. X squared plus y squared equals radius squared. Now which side is the rectangular side and which side is the polar side? Now they're equivalent, they are equal, just like a trig identity is equal. One of them is polar, one of them is rectangular. This is the polar form of it, correct? And this is the rectangular form. Does everybody agree? X and y are rectangular. R and theta are polar. Okay, let's do another true statement. Now let's go to theta and maybe set up, I don't know, sine. So wouldn't that be opposite over hypotenuse? So we'd say sine of angle theta is equal to opposite over hypotenuse. Now looking at that, we want the rectangular stuff all on one side and the polar stuff on the other side. So shouldn't I take my r and times it over, probably? So now look at my true statement. Y is equal to r sine of theta. So which one is the rectangular side? Y, isn't it? And this would be the polar side. Okay, good. So the conversion would be with this. Do you guys see what I'm saying? Okay, let's keep going. Now, adjacent over hypotenuse is cosine, so you have cosine of theta is equal to adjacent over hypotenuse. So then we times up by r. So x is equal to r cosine of theta. And then on this right triangle, oh, but once again, this is the rectangular, and this is the polar form. Now, tangent would be opposite over adjacent. So do you guys see why I said tangent of theta is y over x? So which one's the polar true statement? The one with theta, right? And the rectangular side would be this side. Well, you'll see how we're actually going to use this. It's going to be just, to convert back and forth between polar form to rectangular form. So now we'll use that. That information's still written down up here in the corner. So let's do this. It says, okay, convert from the polar point to instead a rectangular point. Now, so it's getting to this exact same spot, correct? Just by doing instead an xy point. Does everybody agree? So what do we know? Right now we have an r theta, and we want it to become an x comma y point. So what do we know here? Well, what is x equivalent to? R cosine theta, r cosine theta. And then what's y equivalent to? R sine of theta, isn't it? So now can't I plug in what I know? My r is? So we have 4 cosine of 150, and then comma 4 sine at 150. So now let's actually calculate that. 4 times by the cosine at 150. Right here is 150. Cosine's x, so we're timesing by negative root 3 over 2. Comma, the sine, 4 times the sine at 150. Isn't the sine at 150 1/2? And now do you guys see how we've gotten rid of the r and theta? So let's simplify. What's our final answer? 4 divided by 2 is, so we have negative 2 root 3 as our x point, and our y point is 2. And we're done. Now we have an xy point instead of an r theta point. Okay. Okay, this one says, take this polar equation. How do I know it's polar? Because it has r's, not x and y's. It has r's and thetas, but this one doesn't have a theta. So it says, convert this polar equation instead to a rectangular equation. So look at your true statements. Ding, 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 ding over here. What is r squared equivalent to?
X squared.
Yeah, that's the rectangular form. X squared plus y squared, isn't it? So x squared plus y squared equals 4. Isn't now that a rectangular equation? Yeah. So just keep in mind, this is going to be useful for future. If you'll make the connection here, these are stating the same thing. Look what this says. Now, if we square root both sides, that gives r is 2. So when it says we have a radius of 2, you would go to an XY chart and you'd go out 2 units and then you would draw your circle. Does everybody see? Well, isn't that what this says? We have a circle with radius 2. Just different ways of stating the same thing. Okay, let's do this one. It says convert from a rectangular form, which makes sense, that has x and y's, to instead the polar form. So we need to get rid of our x and y's and have only r's and thetas. So let's look here. What is that in polar form? So we have r squared is equal to, 9 is 9. Now we have a y over x squared. Is y over x anything in particular? Tangent of theta, isn't it? That's the polar form. So it would be tangent of theta squared, or tangent squared theta, same thing, right? Now really to write equations, it's kind of similar. You know how we usually write y equals with an equation? We also write r equals, usually. R equals a function of theta. So let's get r alone just for prettiness. What would we do? Square root both sides. When solving and taking a square root, I need a plus and minus. So our r is equal to, because that's a times sign, it's okay to just square root that. So don't we get 3 tan of theta, and then I need a plus or minus. Now it's in its polar form. Is it making sense to everybody? No? Oh, yes. By the way, good job last night. I didn't realize that you were on ballroom for some reason. You're really good. Yeah. Okay. All right, let's do this one here. So it says 3y minus 7x equals 10. Now right away, there's no true statement that we can use, correct? So we're going to have to just kind of plug in what we do know. So if this is going to be 3, instead of y, what would be the polar form? Good, r sine theta. And then we have minus 7, and then instead of x, we better write r cosine theta. And that's equal to 10. So we just replace these with what they're equivalent to. So now from here, remember, an equation usually is r equals. So let's factor out an r. Divide by r, divide by r. So then left is 3 sine theta, good, minus 7 cosine theta. And that's equal to 10. So let's get r alone. Divide that over, very good. So r is equal to 10 divided by 3 sine theta minus 7 cosine theta. And now your equation is written with r's and theta, so that would be polar. I want you to try the next one by yourself to make sure you understand it. I'm not going to go over it if we don't need to. So let's just all work together in your groups. Make sure you understand. So this is a rectangular true statement. It wants the polar true statement. Ready, set, go. Okay, let's hear some answers. R is equal to what? Anyone get a different answer than that? There's another true answer out there that's correct also. No one else got something different. Yeah. 2 cosine minus sine. Well, we better check. We shouldn't have 2 different answers, correct? So are these mathematically equivalent? We better check. Do you agree? Yeah. Let's see if they are. So technically, one of them was plus, wasn't it? Or are they both fine? Okay, let's just go with it. So let's see if they're the same. So if this is true, this one has a negative on top, doesn't it? So couldn't we go to this one, and even though there's not a negative in front, if we really so desired in our heart, could we pull out a negative 1? Yeah. So you're saying this is r is equal to, we have a 3 on top, if we so desired, we could pull out a negative 1. So then divide by negative 1, divide by negative 1. So then left would be negative 2 cosine theta, and now it's going to be plus sine theta. Can I take a negative to the top? Yes. Okay, so now scribble that bad boy out. Is it the same? Yes. Yes, so that's a good thing to remember. Both answers are equal, so there's not one better than the other. Okay, good job. Way to go. I feel like your guys' algebra is going to be really, really well prepared when you guys get to calculus. You guys are doing great. Okay, so let's talk about how a negative r works, a negative radius. Now think about it, you can't go back. Like, you have to create a positive distance, right? Radius is always positive. So this is how negative radiuses work. So what would happen was, instead of a positive radius means you would go to the angle, theta, and then you would walk forward to get to the point. So now right here, what we could do to get to this point is we could still go positive theta, But then instead of going up, we could go back in time, like backwards. Does that make sense? Not back in time, but backwards on the line. So negative r is just working backwards. Walking backwards instead of walking forward, essentially. Because remember, we're just trying to get to a point. So now before we talk about that, another thing to note is look at my blue point right here. This is 2 pi. Now y, well right here is 2 pi, do you agree? 0 and 2 pi. So look, to describe to get to this point, I would be at my origin, 0, 0 right here. To describe to get there, I'd say go to 2 pi. So you'd say, okay, I'm right here on this line, aren't I? And then I'm going out 2 units, going out 2 radiuses. Do you see how I get there? Would it be the same thing to say go to 4 pi and go out 2 units? Yes. So what does that mean? Well, what is it? Can anyone say like a general true statement? Good. You can add or subtract 2 pi. Doesn't that mean that all coterminal angles will fall in the same position? Which we know. So that's why it says r theta will be the same as r comma theta plus or minus 2 pi. So basically, all coterminal angles. Because the theta just gets us in the correct direction. So that makes complete sense. So I'm going to ask you a question here to make a point. If I wanted to write this blue point instead as a negative radius, how could I describe? Now you do have to start at 0. So we have to start at 0, and we work in the positive direction here, guys. So starting at 0, working in the positive, couldn't I say go to angle pi? Go to angle pi, so, and then what would we need to do to get back to here? Walk backwards. You guys see, if we walk forward, wouldn't it be this way? So now walk backwards 2 units, so then we'd say negative 2. That would get me to the exact same spot as 2 pi. Agreed? Does that kind of make sense? Okay, let's graph this. I'm going to actually change this to negative 3. So it says plot the point negative 3 pi fourths. So let's get a visual here. So let's go to negative 3 pi fourths. Well, first of all, right here's positive 3 pi fourths. So look at that distance from 0 to here. So when we go negative that distance, here's our axis, our x-axis we start, and we go negative 3 pi fourths. Would that be right here? It is, yes. So we're on this line. Now, remember, we're starting here at the origin, right? That's where our person's standing. Now, what does it say to do? Now, if you start here, guys, and you went backwards like this, so we went like, we started here, and didn't we go to here? Then our eyeballs are pointing in this direction. Does that make sense, everyone? So now, how do we go negative 3 units? Start at the origin and go back. Instead of going forward, right? Since it's negative, we're going back 1, 2, 3 units. So this is my official point. Let's change to blue. Yeah, it's all directional, exactly.
So it's negative 2, but you wouldn't go down.
Right.
On a rectangular one, down would be negative, but in this one, depending on which direction.
Exactly. That's a good point. You guys see what she's saying? Because I can't state it as you just said perfectly.
So like
you stated it perfectly.
On a rectangular graph, going down is negative and going up is positive, but with polar graphs, it depends on which direction you're facing.
Yes.
On what's negative and positive.
She said that perfectly. It's all depending on direction. Okay? All right, good. So now it says find 3 other polar representations. So let's write another couple true statements to get to that blue point. Because remember, there's a lot of different ways. So now how could we also describe, okay, if I'm going to erase all this stuff right here. How else could we describe getting to that blue point? Another true statement. R theta. What's our radius? 3. Okay, so you're saying it's 3. Okay, then what could theta be? Pi fourths. Isn't that going to get you to the same spot? Okay, good. Let's push ourselves to write one with a negative. So what could we say? So if you went so right right here's, look, right here's positive pi fourths, true? If you go negative pi fourths, that'll put you right here. So you're saying go right here to 5 pi fourths, and then do what? Negative 3 units. Yes. Now, how could you easily do that? Yes, you can, right? That'll put us in the same position. You guys see? So once you have one true statement, you could just add 2 pi or subtract 2 pi, because that would get you in the same direction. Same here, right? Couldn't I add 2 pi? So can anyone, what could I say? Go to 9 pi fourths? And then what? 3. Does everybody agree? Because right here is 8 pi fourths. That's 2 pi. So 9 pi fourths, that will put me here in this right direction. And then head 3 units. Okay, good. Very good. Very, very, very good. All right. We're flying through this lesson. Okay, I just showed you how to do this a second. I just showed you how to do this a second ago. What I want you to do is make sure you can convert this polar point to its rectangular form. Right now it's an r theta. I want you and your groups to tell me what the instead x, y point would be. I'm hearing answers -2, 0. That is true, guys. Why? Because you do r cosine theta, which is 2 cosine pi. Isn't that what x is, everyone? Comma 2 sine pi is r sine theta is my y value, guys. So that's 2 times -1, comma 2 times 0. Does everybody see how the people that already have the answer got -2, 0? Pretty straightforward. Okay, let's do another one. We'll go through this one together. Let's just go quick. So now we'd say x, this is the polar form, r theta. So wouldn't my r be √3? Then we'll put cosine at pi 6. Isn't that r cosine theta is x? Then we have √3 sine of pi 6. That's your y value, okay? So then we have √3 times pi 6. The cosine of pi 6 is √3 over 2, comma, √3 times by 1/2. So now √9 divided by 2 is 3/2. And then right here we would get √3 over 2, wouldn't we? Okay, very good. So now notice you went from r thetas to xy. Xy points are physical distances, which is what those are. Okay, good. All right, doing awesome. Now this one we haven't done yet. So we haven't taken rectangular points and converted to polar points. So pay close attention here. So right here we have the point -1, 1, and that's an xy rectangular xy point. Now we need to write it in polar form. Now here is the thing. Here we went -1 up 1 unit. -1 up 1 unit. Agreed? Now to do the polar form, we need to do, don't we need to describe to go to theta here? And then out some distance? So how can we find that distance? Yeah, the Pythagorean theorem, -1 squared plus 1 squared equals radius squared. 2 equals radius squared. Therefore my r in the xy point is √2. Now it's technically plus or minus √2, I guess, right? I never thought about that. So we're going to choose, can it be either? Let's just make it positive to make our life easier. So let's go √2. R is √2. Well, okay, now that we know we're going √2 in distance from here to here, great. But now we got to figure out what theta is. Now, many ways to do this. First of all, you could go create a triangle. Here it is. Put a theta in. Now we can set up a true statement. Isn't sine opposite over hypotenuse? So you're saying the sine of angle theta is equal to 1 over √2. So you're saying sine of angle theta equals √2 over 2. Right? On that right triangle. All right, well, let's do cosine. Cosine is adjacent over hypotenuse, so our cosine of our angle theta is equal to negative 1 over root 2, which is negative root 2 over 2, isn't it? Now remember, cosine's x, sine is y. Are these xy points on the unit circle? If so, then you're going to use the unit circle. Where does that fall? You always start at 0 and describe it going this way, so isn't it this point right there? Which is? Yep, or 3/4, isn't it? If we wanted to answer in radians. Okay. I can't tell if you're confused or not out there. Okay, let's do this one. This one's not even going to take a whole lot of thought. Over 0 of 2, aren't we just trying to get to that point by r theta? What would our radius be? 2, isn't that 2 units, everybody? From here to here, if I drew a circle, wouldn't that be 2? What would the theta be? It's on the y-axis, right up here, it's pi halves, r theta. So sometimes giving yourself a little visual, like I just did on both of these, really helps. Okay. Now what would happen, guys, if this angle, see how this was on the unit circle? If these were not on the unit circle, then isn't that the one appropriate time? Aren't we trying to find angle theta? That's the one appropriate time to take an inverse in your calculator, because that's how you'd find theta if you didn't have a unit circle. Okay. Yes. Well, so we just went to our right triangle that was created and put a theta down here, like we're still not supposed to do. So then set up a truth statement. Isn't right triangle trick opposite over hypotenuse? Does that make sense? We're just setting up some truth statements. Okay. Now, if you set up a truth statement and it wasn't on the unit circle, then define theta, because right here we're finding theta, we're finding the angle by using the unit circle. But let's say it was sine of theta equals 3/5. That's not on the unit circle, so you take the sine inverse of both sides. But then you'd have to think about it a little bit. Okay, cool. You'll see it. You'll get to the homework and you'll get some practice in. All right, we're almost done with the lesson here. Last example of the day is this. Then the rest of the time will be yours. So it says, describe the graph and convert to a rectangular equation. Because right now, look, they're all r and thetas. It wants it to have x and y equations. So let's see if we can describe it without writing the rectangular form, and then we'll write the rectangular form. What does this say? Like physically, what does that say? So we have a circle, don't we? If a radius of 2, then we have a circle with radius of 2. That's what you'd say. Okay, let's convert it. So what would be the truth statement in rectangular form? X squared plus y squared is how you create a circle, is equal to 4, because it's r squared. Equals 4. This says we have a circle with radius 2, so does this. We're done. That's the answer. That is the rectangular form. Okay, what is this one? This says you have an angle theta of pi thirds. So look at what that means here. Here is our polar grid. We have a theta of pi thirds. So I'm starting at 0 and going to pi thirds. Boom. Well, pi thirds is this line, isn't it? So it's a line. It has all r's. Do you guys see how there wasn't anything about r? It's all r's, infinite r's. So we would say linear. It's a line. And doesn't it have a positive slope? So I'd say line, slope, positive, maybe. Well now, since we know it's a line, what would be the equation of a line? Y equals mx plus b. Now remember, you are literally just trying to graph this exact same line. This is my xy chart here, everyone. Look, xy. I'm trying to literally regraph this pink thing, but as a rectangular line. So what would be the y? Isn't b the y-intercept? What's our y-intercept? So we have y is equal to mx plus 0. So don't we just write y equals mx? Now we need to find the slope. Now slope is rise over run. So you're saying if I have an xy point that I know, all I have to do is do the rise divided by the run, rise over run, and that's the slope, isn't it? So what is an xy point of this radius 1? Well, isn't the radius 1 the unit circle? Then let's go use the unit circle, because that is an xy point on the line. So go to pi thirds, which has this xy point. Now we're trying to figure out the rise divided by the run, because that's the slope. So wouldn't we do y divided by x? So yeah, you are just doing the tangent essentially. So root 3 divided by 2 divided by 1/2. Dividing fractions easy as pie, flip the second, multiply, so don't we get a slope of root 3? So the answer is y is equal to root 3x. Yeah, we're almost done. Okay, now this one, I don't want to just, I'm not going to just, I don't really want to describe that one. I can't see it right now. So I'm like, I'm going to convert to rectangular and then see if I can describe the graph. So I always like to write with sine, cosine, tangent. So isn't this r is equal to 1 over cosine theta? Now I'm trying to convert it. So maybe should I take this cosine and put it on the same side as r? Because then all of our polar stuff's on one side. So we have r cosine of theta equals 1. What is r cosine theta? So my true statement in rectangular is x equals 1. So isn't that a line as well? Line that is, well, how do you graph that line? If I said graph x equals 1, y is changing, but isn't x always 1? So it'd be a line that looks like this. So you'd say a line that's vertical, or a vertical line. So hopefully that helps make it make sense. Set up some true statements, go through and do some algebra, and it does take a teeny bit of thinking, obviously. So you all have polar graphs on your desk. If you have to graph anything, I'd have a unit circle in front of me, and the rest of the time is yours. So look at your homework paper, because it's more updated than my board here. Because r cosine theta is equal to 1. That was one of our true statements. No, sorry. R cosine theta is x, true?